Hello again, and welcome to the IEEE RAS Solidworks series, Module 1.5. Today we're going to be learning about assemblies and mates. Right, so this is kind of the end of, close to the end of our module series, right? This is pretty much where all of the stuff we've learned about creating parts, about taking all our extrusions, our models, and combining them together, right? Because many things that you make and manufacture in life are made out of multiple different parts, and that's what assemblies are really good for. So what we're going to be doing today is we're actually going to be making a hex nut, right? And this hex nut is going to be very simple to make, but essentially it's going to serve us as an example of a part, geometry, that we're later going to put in an assembly. So what I'm going to go ahead and do first is, just as an example, I'm going to orientate myself, use the sketch tool, and I'll go and sketch on the front plane. So if I were wanting to make a hex nut, it'd be pretty simple, right? We could start out with a polygon tool, right? So I could go ahead and draw a polygon, orientate it flat like this, and looks like about 50 millimeters, so that's pretty big, but it really doesn't matter what the size is for this. Later on, you'd want to particularly put down sketch dimensions and all sorts of stuff to make sure that this hex nut is exactly the shape and size you want it to be, but for this demonstration we won't worry too much about that. So now I have this hexagon, as you can see here, right? Great. Now, as we all know, hex nuts, right, when you screw a bolt through them, right, they have to have some sort of circular part in the middle that you can fit the bolt through. So what I'll go ahead and do is I'll go and draw a circle, and let's just draw a circle here. And that looks about good. That looks somewhat what like a hex nut would look like. So what I'm going to go ahead and do now is, now that I have these two different shapes, right, these two different little sections of the sketch, I'm going to go and go to Features, and I'm going to go to Extrude. Right, so I can do Extrude Boss Base. Now as you can see, we have a complicated figure. Now it automatically assumes what we're going to be extruding, right? But if you perhaps wanted to make sure you only extruded the middle, or you wanted to extrude all of this, right, you could select those different contours. But fortunately, SolidWorks is already doing this for us. Right, so this looks about right, yeah, so 50 millimeters out, looks about what a hex nut would look like. So I'm going to go ahead and click the check mark. And just like that, I already have some sort of 3D part that maybe I wanted to add into an assembly. Right. So what I'm going to go ahead and do now is I'm going to go ahead and save this file. So I'll go ahead and go to File, click Save As, and let's see. I'm going to go and find a place. I'm going to go ahead and just save it to my desktop real quick. No problem. I'm going to call this part hex nut. Works great. Okay. So I've saved this part, saved it whatever location I want, and it's there. Great. So what I'm going to do next is I actually want to create an assembly. So for that assembly, I'm going to go to File, click New, File and click New, and instead of taking a part, I'm actually going to go to the section that says Assembly. So click on Assembly, click OK. It's going to take a while to load up depending on how your computer is. But now it says, great. We have this blank screen, it says Begin Assembly. So if we look, it says select a component to insert, then place it in the graphics area, or hit OK to locate it at the origin. So normally you would have to browse for a certain part to begin your assembly. If you were building a robot, more than likely you'd start out with whatever part constitutes the base of your robot, right? So if it was a bottom platform, right, whatever is the most central part of your assembly that's not going to be moving is a great place to start with every part you're adding in. We're going to go ahead and see, we already have a hex nut open since we just created a new file, new assembly. I'm going to go and click on where it says hex nut, or whatever part you want, and it says great. Now I have to have a part selected. You can see now when I move my mouse around, it's there on the screen, and I'm just going to go and click right there, and it kind of drops this place in. Now if you can see that it says the selected component is fixed, it cannot be moved, right? So whatever first part you add into an assembly kind of acts like an anchor for the rest of the document, almost like a reference. Now, okay, we got one hex nut in. Great. Why don't I go ahead and add another? So if I, for any reason, wanted to add in more parts, all I would do is go to Assembly. It says Insert Components, right? Click that button. Just like before, I could add in another hex nut. And now you can see I can move myself around, and we can see I have in three dimensions, I have these parts. One is the hex nut that's fixed, the first one, and then I have the second hex nut, which I can move around. You can see as I move down, the shadow is casted further down, right? Basic part you can move around in 3D. Now, so very simply, whenever you first start up, it's going to be pretty basic how you want to move your components, right? You can readjust things, kind of move it into place a little bit, right? Usually how it'll work is that whichever way you're using this, right, you're going to see that you move your mouse and it's almost like you're moving it along the plane of whichever area you're facing. So if I kind of look how this is right here, I can go and orientate myself to the front plane, and I can move this part around, right? I can move it right in front of it, to the side, right on top, but no matter what, if I switch my views, this distance right here, it only moves in the, if you could say the X and the Y, or the vertical and horizontal on the plane of your screen. So I could go and switch back to the front plane, move to the side, and we will see that when I use my middle mouse button to turn, that depth distance to your screen does not change. Right, so just clicking and dragging is pretty much an easy way to move stuff around. Now, I'm going to go and switch back to an isometric view so it's easier to see. Now, normally if you just want to click and drag things to move components, you could. You could also select the move component, right, and you actually get a specific tool for this instead of just clicking and dragging like you normally would. You have things like free drag, you can drag along assembly X and Y, right, and so on, the Z direction. You know, a very easy way just to move your components along certain directions. Lots of different kinds of freedoms. I like free drag most of the time because, as we'll see later on, if I'm just moving something into place for it to be mated, then you'll have this feature that certain objects can snap to other objects. So, and that kind of brings us into our next topic, right? Not quite, but almost. We have this move component tool, but we also have, if we click the little drop-down menu, we have the rotate component, right? So then you can click an object, and you can begin to rotate it. It's not perfectly exact, right? You can do above delta x, y, z, and you can kind of orientate this in very specific ways, in increments, right? But I typically use just free drag, because I don't always necessarily need to be super exact, but sometimes you need to be, and that's up to you. But as you can see, you can switch your camera around a little bit, drag this object around, move it. I could turn it upside down like this. It's kind of just like you're spinning a circle, right? And you kind of get this objective orientation, then whichever one you want, right? Just a great way where if you are eventually going to mate something, which again goes into our next topic, you know, mating will snap. Basically, it's a method of snapping and fixing objects into place, comparative to the geometry of other objects. And in this particular, right, sometimes we only need to orientate the object a little bit to get something to snap or mate the way we want it to. So I'm just going to go ahead and leave it the way it is. There we go. Maybe switch back to move component. So we got this really weird looking orientated part. Great. So that kind of brings us to the last little bit of what we want to work on, right? So what we want to do is we want to learn how mating works. Now, mating is up here in the top left-hand corner. You'll see where it says mate, right? So a mate basically is a way of fixing a component to another, right? And it does this by geometrical relationships. So if I go and click mate, right, you'll see it'll bring up this menu. So maybe I want to mate or fix one surface to another. So maybe I want to stack these hex nuts on top of each other, right? So I'm going to go ahead and take this hex nut, I'm going to click on this surface and this bottom surface, right? Because I want to kind of mate or connect those two surfaces. Now I'm going to show you that again, right? I click the bottom and I click the other one, right? I click these two faces, and if you look at the little adjustment the program makes, it's very hard to see, but now you can see it lines up those two planes, right? And if you look back at the left-hand side where the mate menu is, right, it's considering a coincident mate, right? So I just made those two planes coincident. So if I go and hit the check mark, right, we can see that these two planes are not coincident. It looks like I'm moving it around still normally, but as you can see, if I go and go to a side view, right, no matter what I do, I'm always moving in that plane, which is why you see I can't move it up and down vertically. Right, I'm always fixed to that plane. Even as I get closer, I can move the two off, and it still is fixed to that plane. And so, what we have is that's our first successful mate. It's worked great, exactly how we want it to. But as you can see, maybe this isn't exactly what we want. Maybe we want to orientate them and stack them just like you moved one on top of the other. Right? And so again, there's more relationships that we can define if we want to permanently fix this into place. So I'm going to go to the mate tool, and if I want these to be like they're perfectly stacked on top of each other, right, I gotta want to define and kind of confine this relationship in all three dimensions, right? So by making those two faces, those two planes coincident, it's not going to be moving around at all. Maybe I can make this line right here and this line coincident. Great. So now these two lines are coincident. Basically, the two objects are sharing the same edge. Right, so if I go and hit the check mark, we will see now that they're sharing the plane, and that no matter how I orientate this, no matter how I move it around, it's always sharing that same line. Imagine it extends into infinity. But as we can see, there's still one-dimensional direction that we're not fixed in. And you could also totally leave the document like this if you wanted to. But I don't want to stack these up perfectly. So yet again, I'm going to go ahead and take this line of the bottom hex nut, and the top line of the top hex nut, I'm going to mate them together, right? So the three things I've mated this edge right here that you can see, I've mated the second edge, right? And then I've also mated the plane below it, right? These three mates have basically allowed me to fully define this object. So if I try to go and exit out of this and I try to move this part, right, it says the selected component is fully defined. It cannot be moved, right? Because there are geometrical relationships that prevent it from moving in any other direction because they're considered in actual 3 dimensions and they lock it down, right? So now you can see I have fully fixed one hex nut on top of another. Great, right? You know, those are your constraining things in translational axes in this case. But of course, due to the nature of my mates, it also defines it in 3 rotational axes, right? So if I go to rotate component, I cannot rotate this component, right? Because rotating in any shape or form would break the current existing mates, almost like they're welds. So, real quick, we're going to do one more thing. We are going to go ahead and, we've got a check mark here. I'm going to go and add in one more component. So I'm going to go and add another hex nut. Right, let's just place it right there. There we go. As you can see, it's intersecting the other part. That's fine. I'm just going to go and click and drag it out of the way. There we go. Right, so you can really define a lot of different kinds of mates. Right, I talked about linear ones with faces and planes, but there's also, as we said, like the side, the edge, can be defined as well. But not only linear edges, but curved edges as well. So I'm going to click the mate tool, and I'm going to go ahead and mate this circular section right there with this circular section. And as we can see, because of the 2D nature of the circle, this can only rotate in one direction. It can't be moved at all either, right? So because of that circle, I've fully locked it down, and now when I click on it, I'm only really rotating it, right? So because of that one edge that they now share, the circular edge, this is fully defined. Now again, if I wanted to, I could go ahead and mate the inside circle, inside cylinder with the inside cylinder, right? And now that plane surface, if you consider it like a surface as a plane, or no, yes, if you consider the surface extending out into infinity, almost like a wrapped around plane, right? They have to share those. Those are coincident, right? You could also change the nature. Actually, those are concentric, sorry. Since they're circular objects, they're concentric, which means the center of one drum or circle is concentric or in the middle of the other, right? There's also things like perpendicular, where I can make these two objects perpendicular, parallel, right, where now they're kind of sharing this object here. Really, it's up to you to explore these yourself. But the important thing is it grants you a lot of freedom on how you want to alter these parts, right? Now, as you can see, because I'm just kind of linking these surfaces, I can actually now move it in this direction along the kind of central axis of these two circles that they've been made along, right? Before I couldn't do that because when I made the circles, they were actual specific edges that were linked together. But this is just, the drums are almost like planes. Much how a plane allows you to move in two axes, this kind of circular section surface area would allow you still to rotate and also to move around the other way. And if I wanted to further extend this mate, I could go ahead and link in these two, right? And now you can see this has been constrained in a different kind of way, right? So as you take multiple different kinds of components, right? If I wanted to, I could design a quick screw and then put it through these. So actually, that's a fantastic idea. Let's do that real quick. So I'm going to go ahead and delete this hex nut here. And I'm going to just place a quick screw. So I'm going to go ahead and go to the, if I go to evaluate, I'm going to go to the measure tool that I've learned about a little bit. Right, so I can measure certain details. So the diameter of this is 54.37 millimeters. Great. So I'm going to go ahead and see what the, if I go to measure, see what the two distances between the two faces, that's about 50 millimeters. So I'll make a 100 millimeter bolt or something like that. So I'm going to go, or some sort of center area there. Great. So I'm going to go ahead and file new, make a new part. Great. So I'm going to go and sketch, make this real quick, not to hold y'all any longer, right? Go ahead and go to the front plane, go ahead and create a, just kind of like a top to this, right? There we go, it's kind of bigger. Perfect. I'm going to go and features extrude this. Sorry, features extrude this about 10 mil, or yeah, let's make it 20 millimeters. There we go. And then I'm going to go ahead and sketch on this document here, just to the front. And I think I'll go ahead and start out with another circle, except this one will be smart dimension to the diameter, I believe, 50. Let me just double check for a second here. Wrong document, 1 second, everybody. Let's see, if we go back to our original assembly document, back to our measure tool, let's double check that again. Yes, 54.37. Gotta write those measurements down. It's a lot easier this way. So now I'm going to go back to our document here, 54.37. So I'm going to go ahead and readjust my camera angle. 54.37. And actually, let's make it just 54.37 to make it exact. That's units, or just millimeters. We'll default, right? So there we go. And I'm going to go and feature, extrude this to a distance, so let's do 100 millimeters. We can make it a little longer. Let's do 150 millimeters. This is a pretty weird looking screw, but that's alright. Right? The purpose is there. So let's go ahead and go back to our original document here. There we go. So I'm going to go in Assembly, Insert Components. Currently not open because it's not saved, so let me go ahead and save that new document. File, Save. Make this like a bolt, essentially. There we go. Let's go back to our assembly. I'm going to insert components, a bolt. Right, and I'll probably insert it close to this side. Perfect. Okay, so now as you can see, if I wanted to, I could go ahead and mate, and I'm going to make this surface constraint. Actually, not quite what I wanted there. Let's try that again. Let's make this cylinder, there we go, this cylinder concentric with this cylinder. So if you wanted to fit some sort of bolt into a nut, right, imagine you have some sort of medium here, that's usually how bolts work, and now you can see I have fixed it in. So now if you could imagine a bolt fitting into the nut, right? And then of course those other things. If I wanted to link this plane up with this one, right? Now this bolt is fixed into place, right? If it was supposed to be attaching something, it would. You know. So really it's up to you to design the parts and then use these geometric relationships inside your document to make an assembly, you know, that details how your parts put together. If you're designing a robot, right? How does the chassis fit together? And that's actually a great segue into what we'll be learning next time. In Module 1.6, you'll be learning about how to make mechanical and robot chassis design, and we'll be using a little bit more of assembly, but going over some pre-made parts and how you can end up actually taking those other resources and then putting all that together to get a full virtual design of whatever you're going to be building. Alright, so thank you all very much, and I can't wait till I'll see you all next time.